Next we will go to now dual nature of, we will go to a new chapter, that is the dual nature of radiation. Dual nature of radiation. Dual nature of radiation. What is the meaning of dual nature of radiation? In this chapter we shall discuss about de Broglie wave, de Broglie wavelength, de Broglie wave, etc. What is dual nature of radiation? Dual nature of radiation means that, as you know, radiation has got two natures. One, sometimes it behaves as a wave, sometimes it behaves as a particle. So, by taking wave concept of radiation, interference, diffraction, polarization, etc., I have explained. But you have to explain photoelectric effect and Compton effect, etc. This wave nature of radiation would not explain those effects. So, in order to explain those effects, Planck assumed that radiation consists of small packets. Radiation consists of small packets. Radiation consists of small packets. Small packets of energy. Radiation consists of small packets of energy. According to Planck, that radiation consists of small packets of energy. Each packet is called a photon. Each packet is called a photon. Important. What is a photon? Exam question may come, one more question. What is a photon? Packet of energy, that is photon. Energy carried, energy associated with each photon, energy associated with each photon is equal to h nu. Energy associated with each photon is equal to h nu. What is h? H is Planck's constant and nu is frequency of radiation, where h is Planck's constant and nu is frequency of radiation. Frequency of radiation. So, this is your Planck's quantum theory of radiation. That radiation consists of small packets of energy. Energy associated with each packet is called a photon. Energy associated with each photon is called h nu, where h is Planck's constant and nu is frequency of radiation. That is, E is equal to how much? H nu. E is equal to h nu. So, this is energy associated with a photon. E is equal to h nu. So, what is this Planck's constant? Value of Planck's constant, h is equal to how much? 6.6 10 to the minus 34 joule second. Value of constant is. So, by this, by quantum theory of radiation, Planck want to explain photoelectric effect as well as your Compton effect. To explain interference, diffraction, etc., wave nature of radiation was taken. So, in order to explain all the effects of radiation, it is taken that radiation behaves as a wave as well as behaves as a particle. Radiation, in order to explain interference, diffraction, polarization, etc., you have to explain interference, diffraction, polarization, etc. Wave nature of radiation is considered. 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 In order to explain photoelectric effect, which we will discuss later, photoelectric effect, Compton effect, etc. Compton effect, etc. Particle nature of radiation is considered. 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 Particle nature. So, radiation behaves as a wave, also behaves as a particle. Therefore, radiation behaves as a wave and also as a particle, hence it has got a dual nature or double nature. So it has got a dual nature or double nature, dual nature of radiation. If it is radiation behaves as a wave, what is this wavelength? Wavelength of radiation. Wavelength of radiation. How much is the wavelength of radiation? What is this wavelength? How much is the wavelength of this radiation or wavelength of photon? Wavelength. How to calculate this wavelength of photon? Wavelength of a photon. Photon behaves as a particle, also behaves as a wave. So, what is the wavelength associated with the photon? A photon behaves, has a wave nature and particle nature. So, what is the wave nature and particle? Then what is the wavelength associated with a photon? Wavelength of a photon. Wavelength of a photon. Wavelength of a photon. How to calculate wavelength of a photon? You know E is equal to what? Energy associated with a photon is equal to h nu. At the same time, E is equal to how much? As you know, mc square from Einstein's mass and its relation. E is equal to mc square. E is equal to mc square. So, mc square is equal to what? H nu. mc square is equal to h nu. So, mc is equal to how much? H nu by c. That is equal to h by c by nu. H by c by nu. And this h, what is c by nu? Velocity by frequency is equal to what? H by lambda. H by lambda. So, what is lambda? So, lambda is equal to what? H by mc. H by mc. Planck's constant, mass of the photon and your velocity. E is equal to h nu, E is equal to mc square. So, mc square is equal to h nu, mc is equal to h nu by c, h by c by nu. C by nu is velocity by frequency wavelength, h by lambda. So, lambda is h by how much? H by mc. So, this is the wavelength of a photon. So, since a particle is behaving as a wave, photon is behaving as a particle as well as a wave. Therefore, when a particle moves, when a particle is moving, it is associated with a wave. A moving particle is, since moving particle is always associated with wave, that wave is called de Broglie wave. Therefore, a moving particle is always associated with a wave. A moving particle is always associated with. This wave is called de Broglie wave. This wave is called de Broglie wave, and the wavelength of the wave is called de Broglie wavelength. De Broglie wavelength. De Broglie wavelength. Wavelength of the wave is called de Broglie wavelength. So, what is that de Broglie wavelength? You can look at this formula. From that, you can calculate de Broglie wavelength. If m is mass of the particle, v is equal to velocity of the particle, then lambda is equal to what? S by mv, or S by what? S by p. What is p? P is momentum, linear momentum of the particle. 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 S by p. Lambda is equal to S by mv or S by p. This is a very important relation. De Broglie wavelength. Lambda is equal. You may be asked in the examination, so what is de Broglie wave? What is de Broglie wavelength? Or numericals based on this. We will also solve numericals from this. De Broglie lambda is equal to S by mv. This same relation can be given in form of total energy of this. This is the formula involving Planck's constant and your linear momentum. H is Planck's constant. The value of Planck's constant you have to remember. 6.6 × 10⁻34 joule second. H is known, E is known. So, de Broglie wavelength you can also calculate. De Broglie wavelength in terms of energy, in terms of kinetic energy. De Broglie wavelength in terms of kinetic energy. How to write de Broglie wavelength in terms of kinetic energy? You know your kinetic energy of the particle, half mv square, that is E. Now, we will express de Broglie wavelength in terms of kinetic energy. How to suppose in the examination energy is given to you, how to calculate de Broglie wavelength, put that particular formula. So, this becomes what? M square v square is equal to how much? 2mv. M square v square is 2mv. So, mv is how much? 2mv root over. mv is 2mv root over. So, what is your de Broglie wavelength? De Broglie wavelength is equal to lambda, that is equal to S by mv. Now, that becomes what? S by mv 2mv root over. This is the same formula, same thing, but expressed in different form. That is expressed in form of kinetic energy. Mass of the particle is known, kinetic energy is known, Planck's constant is known. You can directly calculate. Also, there is de Broglie wavelength in terms of temperature. De Broglie wavelength in terms of temperature. How to write d Broglie wavelength in terms of temperature? If it comes in form of temperature, suppose question comes in form of temperature, you can also calculate that. As you know, what is the energy associated? Energy is equal to 3 by 2 kT. Energy is equal to energy associated with the particle is 3 by 2 kT. What is K? K is Boltzmann constant. K is Boltzmann constant. And what is T? Absolute temperature. Absolute temperature. Here, now you can put the value here. So, your d Broglie wavelength is equal to lambda, that is equal to h by 2 me root over h by 2 me root over. Now, here you can put the value of E in form of temperature, that is equal to what? H by 2m. E is how much? 3 by 2 kT root over 2 cancels, h by what? 3m kT root over. So, if the temperature is given and mass of the particle is given, you can also calculate d Broglie wavelength. So, d Broglie wavelength in terms of momentum is known to you, in terms of energy is given, in terms of temperature is also given. Now, we will find out d Broglie wavelength of an electron. D Broglie wavelength of an electron which is accelerated through a potential of V volts. That is a very important formula. You have to remember that formula. D Broglie wavelength of an electron. D Broglie wavelength of an electron. And a very important formula I will find out here. So, when an electron will move when it is accelerated through potential difference. Suppose the applied potential is equal to V. Suppose the electron is accelerated. Suppose the electron accelerated through a potential difference V volts. Potential difference V volts. As you know, d Broglie length found out in terms of energy, in terms of temperature, in terms of momentum. So, you can find out here energy and put it in energy in terms of the potential difference. Then what is the energy associated with electron? Energy associated with electron. Energy associated with the electron, that is the total work done. That is called E into V. When electron is accelerated, the potential difference of V volts, what is EV? EV is equal to how much? Half mv square, half mu square. U is velocity of electron. U velocity of electron. M mass of electron. Mass of electron, as you know, 9.1 into 10 to the minus 31 kg mass of electron. So, what is your d Broglie wavelength? D Broglie wavelength is equal to lambda, that is equal to how much? S by 2me root over. We have already found out 2me root over. In place of E, energy, let us put what? Work done, half mu square, that is equal to total energy E. That you can put here, H by what? 2m into EV. E is equal to 2m EV. So, what is the final formula? the final formula is how much? H by 2m eV. H is Planck's constant, m is mass of electron, E is charge of electron, and V is the potential difference applied. Now you can put the values. H is how much? 6.6 10 to the minus 34. Root over of what? 2. Mass of electron 9.1 10 to the minus 31. Charge of electron 1.6 10 to the minus 19 into V. If you put all these values, you can put the values 2 into 9.1 10 to the minus 31, 1.6 10 to the minus 19, etc. Put everything, it becomes how much? 12 point, this result will be 12.3 by root over of V angstrom. Remember this formula, this becomes 12.3 by root over of V angstrom. If in the examination it is asked, an electron is accelerated through this potential difference, calculate the de Broglie wavelength. You can straight directly put this formula 12.3 by root over V angstrom. 1 angstrom is how much? 10 to the minus 10 meter. This will come in meter. After converting to angstrom, it becomes 12.3 by root over V angstrom. You can calculate. From this you will get in the examination, either this is not important for long question, but you will get short question and also numerical from this. Some of the question is like this: calculate de Broglie wavelength, calculate de Broglie wavelength associated with an electron, accelerated through a potential difference of PD of 100 volts. Very simple question. This question will carry 2 marks in examination. A potential difference of 100 volts is applied to an electron, and you are asked to find out the wavelength associated with the electron. From the very concept also you can find out energy work done is how much? E into V, that is half mv square, half mu square energy. From that also you can calculate. But if you know the formula, remember the formula, you can directly put here. What is the formula? De Broglie lambda is equal to how much? Straight put the formula 12.3 by root over of V angstrom. This is the formula. 12.3 by root over of V angstrom. So this becomes how much? 12.3 by root over of V. Root over of V means what? Root over of 100. Root straight. Within 1 minute you can solve the problem. Root over 100. That is how much? 12.3 by how much? 10. That is 1.23 angstrom. 1 angstrom is how much? 1 angstrom is equal to 10 to the power how much? Minus 10 meter or 10 to the minus 8 centimeter. 1.23 angstrom. Some of the questions can be like this. The variety of questions can be from this chapter. Calculate the momentum of a photon. Calculate the momentum of a photon. Momentum of a photon. Calculate the momentum of a photon associated with radiation. Associated with radiation. Momentum of a photon associated with radiation of frequency. How much is the frequency? 5 into 10 to the power 13 hertz. 5 into 10 to the power 13 hertz. The frequency is given to you and you are asked to find out the momentum of the photon. How to calculate the momentum of the photon? This question will either carry 2 marks or 3 marks also. Frequency is given to you and you are asked to find out the momentum. How to calculate the momentum? You know lambda is equal to what? S by P. Lambda is equal to S by P. This is from de Broglie wavelength. Lambda is equal to S by P. So P is equal to how much? What is P? P is equal to how much? S by lambda. Now the value of H is remembered. But how much is lambda? Lambda is not given in the question. Frequency is given. So you must bring lambda to the form of frequency. How to bring lambda to form of frequency? That is what? S by lambda. Lambda is equal to what? C by nu. What is C? C is velocity of light. C is velocity of light. Velocity of light. C is velocity of light. Yes, that becomes what? H nu by C. Now put the values around. Put the value of H, put the value of nu, put the value of C. What is the value of H? 6.6, 10 to the power 34. You have to remember this value of Planck's constant, you have to remember. 6.6 into 10 to the power minus 34 into nu. Nu is given to you 5 into 10 to the power 13. C, velocity of light, 3 into 10 to the power 8. You have to remember this value, 10 to the power 8. P. So this becomes how much? 6.6 into 5 by 3 into 10 to the power. How much 10 to the power will be there? 10 to the minus 34, 10 to the power 8, 10 to the power 13, 10 to the power 5. So this becomes how much? 10 to the power, how much it will be? 10 to the power minus what? Minus 29. 8, 13 into 5 cancels, minus 34, minus 29. What is the unit? That is most important. You must mention the unit. Momentum is what? You know momentum? mv. M is mass, v is velocity. So this will be mass will be what? kg, velocity will be what? Meter by second. This will be the momentum. kg meter by second. This is kg meter by second. Very simple question you can be also asked. Calculate energy by photon having frequency like this. Very simple questions are asked in the examination. Calculate energy of a photon. Energy of a photon having frequency 10 to the 15 hertz. Energy of a photon having frequency 10 to the 15 hertz. How to calculate that energy? Very simple question, 2 marks. This will be 2 mark question. I am discussing the problem because the problems are important in physics. Simply reading theory, you can answer 21 marks. Rest 14 marks depends on problems only. So E is equal to, put the very simple formula. Remember this. What is the energy of a photon? The formula is h nu by h nu. E is equal to h nu. You know the Planck's constant, you have to remember. Frequency is given. Very simple way, 6.6, 10 to the minus 34. Nu is equal to how much? 10 to the 15. So this becomes how much? 6.6 into 10 to the minus 19. Next is important is unit. You have to mention the unit. What is the unit? These are given in MK system. So what is the unit? This was joules. Joules. Suppose in the examination they have asked calculate the energy in electron volt. Mostly they ask to calculate the energy in electron volt because in modern physics or atomic physics, electron volt is important unit of energy. So how to calculate this energy in electron volt? What is the meaning of electron volt? Electron volt is how much? What is electron volt? Electron volt is the amount of energy gained or amount of work done when an electron is accelerated against a potential difference of 1 volt. So, 1 electron volt, 1 electron volt, that is 1 eV, most important unit of energy in atomic physics and modern physics. So, that is 1 electron volt is equal to 1 eV, that is 1 eV means amount of work done, that is your amount of work done, amount of work done to accelerate an electron against a potential difference of 1 volt, potential difference of 1 volt. So, this is the meaning of 1. In the examination we have asked define electron volt or what is the meaning of 1 electron volt. 1 electron volt is how many joules, like that. Amount of work done to accelerate an electron against a potential difference of 1 volt. So, how much is that? That is 1 charge like E 1.6 10 to the minus 19 into 1. That is 1.6 10 to the minus 19 joules. So, remember this is very important. So, 1 eV is 1.6 10 to the minus 19 joules is a very important unit and very important information also. So, 1 eV, remember this, 1 electron volt is 1.6 10 to the minus 19 joules. 1 electron volt is 1.6 10 to the minus 19 joules. So, in the examination, if they have asked express this energy in electron volt, you can also express. How to express it? We have already expressed the energy in joules. So, E is equal to how much? 6.6 10 to the minus 19 joules. So, it will be how many electron volt? 1 electron volt is this much joules. So, this much joules will be how many electron volt? So, that is equal to what? 6.6 10 to the minus 19 by 1.6 10 to the minus 19 eV electron volt. This is the energy associated. That is 66 by 16 electron volt, or you can make it 33 by 8 4.1 eV, that is 4.1 electron volt, 4.1 electron volt. So, if in the examination you are asked to express in electron volt, you can also express in electron volt, or if not asked to express in electron volt, you can simply leave here 6.6 10 to 19 joules. So, this is how the very important unit in atomic physics and modern physics, what is the electron volt, what is the definition for electron volt, and how much electron, 1 electron volt is how many joules. So, this is about your de Broglie concept of matter wave. This is called matter wave. Matter wave means matter is associated with a wave. Matter has got a wave idea, wave concept. It behaves as a wave. That means a moving particle is always associated with a wave. If it is associated with wave, it must have a wavelength. What is that wavelength? The wavelength is lambda by s, lambda is equal to how much? S by mv. And this concept was given by de Broglie. So, this is called de Broglie wave, and the wavelength is called de Broglie wavelength, and the expression for de Broglie wavelength is lambda is equal to s by mv. So, from this concept of matter wave, you will not get long questions in the examination, you will get short questions, definitions, and also numericals. Numericals are important, like this numericals will be asked. Numericals of this type will be asked in the examination. In the next class, we will go to photoelectric effect. What is the photoelectric effect? That is also based on this particle nature. Photoelectric effect means what? Photo means what? Photo is light, electric. From light you will get electric. How? We will put radiation a particular metal, from that charges, electrons will come out. We will accelerate the electrons and get current. That is your photoelectric effect. So, when radiation is used in a metallic surface, electrons rejected from it, and from the electrons will get current. So, from radiation we will get current, that is your photoelectric effect. Tomorrow we shall discuss about photoelectric effect. Thank you.